Hello, everybody. Welcome to my new course. My name is Taimurish Lal, and this is my new course where the goal is that you'll get insights and learning into one of the most transformative technologies of this century, which is quantum computing. Just like AI, quantum computing is going to revolutionize industries. It's also going to introduce new sorts of security risks that's going to impact everything from cryptography to data protection. So, in this masterclass, we're going to explore the fundamentals of quantum computing, what are the threats it's going to bring, and what are the steps you need to take to prepare yourself and your company for the quantum era. You're going to learn about quantum resistant encryption and what are the vulnerabilities that you need to make sure of. So, by the end of this course, you'll have a good understanding of the risks and opportunities that quantum computing brings. So, these are the goals of this course. Like I said, you're going to get an overview. You're going to find out what makes quantum computing different from classical computing. What are the risks and security implications for quantum computing? And then I'm going to show you how you can implement like a quantum computing risk and security program. And we're going to be using case studies because that always helps to contextualize these sort of things, and it shows you how you can actually go about practically implementing it. So just a quick overview about me. My name is Taimur Ijlal. I'm a multi-award winning cybersecurity leader. I'm also a speaker, instructor, a teacher. I also coach people on cybersecurity. I have a small YouTube channel called the Cloud Security Guy, and also I'm a best-selling author and course creator. I've written multiple books on cybersecurity. A few of them are there on Amazon. You can check them out. I'm there on LinkedIn or X or Substack. Just I'll put a few links if you want to get in touch with me. Happy to do that. But let's go ahead. And what am I talking about here? So, when we talk about normal computing, traditional computing, or classical computing, it uses bits, right? Bits, without diving too deep into the technicalities, bits are the basic bit of information which classical computers use. Every bit can represent either a zero or a one. So, it's a binary system, right? And these systems are great. I mean, they've served us for decades now. And they're very good for everyday tasks and computations. And that's how everything is working, right? Word processing to the internet. However, what happens is it struggles with complex problems like simulating medical data or factoring large numbers, which is where the new thing comes in, which is quantum computing. Now, quantum computing is a revolutionary type of computing, and it uses the principles of quantum mechanics, and it's like a branch of physics that deals with the behavior of particles at the atomic and subatomic level. If this is too much for you, don't worry about it. I'm going to explain it in a very, very simple manner. And the good thing about quantum computing, very similar to AI, you do not need to dive deep into the technicalities of it. As long as you have a high level understanding, you will be able to understand the risks that are there. But simply put, unlike classical computers that rely on binary bits to represent data is either one or zero, quantum computers, they use quantum bits or qubits, we call it, which can represent both 0 and 1 simultaneously. At the same time, it can be 0 or 1. And it is fundamentally different from classical computing in the way it processes information. And most importantly, it has the potential to solve complex problems much, much faster than classical computers can. Right. And so this is like what I want you to understand. Right. This is how, if you remember the previous slide, we saw traditional computing 1 and 0. There, in quantum computing, you have qubits which can be 0 and 1. And this is what gives quantum computers their power, right? The advantage that they have over classical computers, and which gives them the ability to solve such very, very challenging problems, right? That a classical computer cannot handle. So, and the same power, this power which I'm talking about, that same thing leads us to the next part, which is the need for quantum security. Now, this is something which is like very, very, what do you call, something which people are not ready for, right? And quantum computing poses significant security risk, especially when it comes to cryptography and cybersecurity. Cryptography or encryption is everywhere. Right now, this course you're probably accessing on a web browser, right? And it is using cryptography to make sure that the data between yourself and the browser and everything is encrypted, right? And cryptography today, it relies on solving mathematical problems, which are nearly impossible for classical computers to solve. But quantum computers could potentially break these encryption methods in a matter of minutes. And this is where the whole problem comes in, right? So you need to have quantum resistant cryptography. And there are attacks which I'm going to talk about called harvest now, decrypt later, which is attackers are already uh, storing data. Even though it's encrypted, they don't worry about it because But they know that when quantum computers become available, they will be able to decrypt this data. New types of attack vectors are emerging. NIST has recently released its standards on post quantum encryption, and even your existing standards are going to get revised. You have standards like PCI DSS, which mandate certain standards, right, for encryption. All of those standards are going to get changed if you look at the future. So that's why it's very, very important. The quantum computing might be in the near future, but the risk is right now. That is what I want people to be very, very clear about. The risk is right now when it comes to quantum computing. So I hope you understand now why you need to study this, right? Because the quantum computing and quantum era, it poses a serious threat to existing cybersecurity, and it's gonna make our traditional protections obsolete. The encryption and everything which we rely upon for the sensitive data and critical infrastructure. So that's why you need to prepare for emerging threats. I need to have a proactive approach to post quantum cryptography. I'm going to help you develop a quantum risk strategy that will like future proof you for the future regulatory landscape, right? It will help you prepare for what's going to come in. And also, quantum computing is going to introduce new sorts of careers, right? New careers are going to come out of quantum computing, just like AI introduce new careers in cybersecurity. You have things like AI security, Gen AI security. So you're gonna have a career advantage if you study this topic. So, and what are the misconceptions which I see? I talk to a lot of people, and these are some of the funny misconceptions I see. Right? It's too far away. People say that many believe that it's decades away. I don't need to worry about it. However, advancements in the field are happening very, very fast, and experts believe that we could be very, very close to quantum computing. And believe me, when it happens, it's going to happen very, very fast. At that time, you will be scrambling to make sure that your encryption protocols are secure, and you won't have time. And the other thing is, people say it's an IT thing. Like this is purely an IT concern. It's relevant to only to IT departments, whereas its implications go far beyond whether you are in finance or healthcare or government. All of your encryption protocols are going to get compromised if you do not change it. You need to know programming. Again, I've seen a lot of people say you need to know quantum programming. No, you don't. To understand, just like AI, you don't need to know statistics or have a PhD in mathematics to understand AI. You don't need to do that for learning quantum computing. Or you need to know encryption. You need to know have a high level knowledge of encryption. You don't need to like deep down into mathematical algorithms and how these algorithms are working. You need to know like a little bit about how encryption works, but you don't need to be a cryptographic expert, right? And again, people say it won't affect me or my job. I can assure you, if you're in cybersecurity, your career will get impacted by quantum computing. It's going to disrupt a lot of industries, no matter which industry you're in. And lastly, this is the funniest. Like people say that, yeah, I'm going to wait and do a certification on this when it comes out. This is waiting until quantum computing is mainstream before gaining knowledge will leave you behind the curve. Forget your career. You're going to be in a serious issue when the quantum hacking happens, and then you'll be scrambling and trying to keep up with the latest developments. Just like with AI, once AI became mainstream with ChatGPT, it moved very, very fast, and people were scrambling and getting left behind. So in summary, quantum computing is not as far off or technical as it might seem. Its impacts are going to reach far beyond IT, and it's going to touch various industries and roles. So that's why you need to start learning it now. Okay, don't wait. As you can see, there have been many, many happenings within the industry. NIST have released their standards. Cyber experts are warning of the looming quantum hacking threat, right? Uh, like already magazines are warning about how attackers are going to be targeting quantum computing when it comes out. So they're going to be attacks specifically targeting quantum computers. Just like AI brought about new attacks, we're going to have new quantum specific attacks. So I hope you understood now the need for quantum computing and why you should be excited and a little bit scared also of this new era which is coming. So who this course for? Like I said, I've made this course to be practically understood by if you're a cybersecurity professional, you're a developer, you're a risk professional, a CIO, CTO, CISO, or anybody interested in quantum computing, risk, and cybersecurity. I'm not specifically mentioning any technology or product, as that's not the point of this course. It's completely vendor agnostic and tech agnostic. Concepts are more important to make sure that these points are relevant from now, the 10 years from now, when quantum computing has become mainstream. So it's very, very important. And how do you use this course? Very important. You understand quantum computing and the landscape, learn about the new risks which are coming out, assess your cryptographic risks, and then I'm going to help you create a quantum risk and security roadmap for your company. And that's actually going to be your project also for this course. I don't want you to just listen to me babbling on for like hours, and forget about it the next day. I want you to take this knowledge and actually create like a quantum strategy for your company, and starting now, because this is the time to start. And it's not like you have to wait when quantum computing becomes mainstream. This is one of the most exciting technologies. I think after AI, this is the most disruptive thing which is going to happen. So it's great that you've taken this step to start learning about this. I hope you are as excited as I am to learn on this topic. Thanks, and let's start our journey. I will see you in the next lesson. Thank you.